Under IP addressing, we saw different classes. Class A, which ranged from 1 to 126, B 128 to 191, C 192 to 223. And we learned how the range is derived. When you see an IP address 10.223.128.10, we should know that this is class A. Don't see these octates. If you see these octates, sometime you may tend to think that it is class C or B. No, we have to see only the first octate, based on which we will decide what class this belongs to. And secondly, we saw about the two subnets that cannot be used. For example, here 127 is missing. Any number IP address beginning with 127 is it's not a valid IP address to be assigned to the device. 127 is for self-diagnostic test. Lubeck. Lubeck address. Secondly, as you said, APIPA, Automatic Private Internet Protocol address, which will be generating 169.254 and any. So this is dynamically generated address. The operating system waits for DHCP to provide an offer. Unfortunately, there is no DHCP server available in the surrounding, and the operating system waited enough and says now you need to check DHCP. So there is some issue with the DHCP. So this 169.254, if we do not have, then we will not have an idea where the problem is. See, when a device is not going online, the problem may be on the device itself, the host, the computer itself. The problem may be on the link connecting the switch. The problem may be on the switch itself or on the DHCP server somewhere. We will not know where the problem is if this is not generated. As soon as you get 169.254, it clearly says that your device is good. And there is something wrong between your device and the DHCP server. Maybe the problem is on the DHCP server itself or in the path between the DHCP server. Maybe there is a link broken, something like that. So this is also helping us to troubleshoot. Now, the mask. There is a reservation done for network. For example, in class A, as we saw, first octet means the 8-bit is only the network. The remaining 24-bit is host. So because the 8-bit is already network, in order to say it is already network, you're not supposed to do any changes to that first octet. It is already network. In order to say that reservation thing, we have mask, meaning all the bits of that octet is on and the rest of the octets are off, 0, which means they are not reserved. They can be altered at any way that you like. So these bits in this octet, for example, 10, 0, 11, 15. And the mask is 255 dot 000. What does it mean? This means that you got a privilege of changing this 0 to 100, this 11 to 111, this is 115, but you have nothing to do with this. You should not change this at all. So the mask tells out of the 32-bit in the address, what all are reserved, what all cannot be changed, what all the bits can be changed as per your requirement. Now, not always. You see, when I do subnetting 10.11.11.15, 10.11.11.15, there are two computers with this IP address. The mask of this is 255.0.0.0. The mask of this is 255.255.0.0. So even though the IP address appears to be same, but they are not same. Why? This is 10 network. In that 10 network, the host ID is 11.11.15, whereas this is 10.11 network, in which the host ID is 11.15. So the mask actually shows you how many bits are reserved for network. That's it. It is not going to provide you the class, because when you do subnetting, not when you do subnetting, we always do subnetting. It's not like we will have some classful networks in the real world. No, we'll always have subnetted network. Of course, as you said, yes, we were having the default masks. When it was classful days, we used to say class A means 255.0.0.0 is the default subnet mask. Even today it is default subnet mask, but we don't use classful network nowadays. Yeah. So class B is 255.255.0.0. We call this as default subnet mask. Class C is 255.255.255.0. Default subnet mask. Yeah. That's right. So if you take class C, this is the default reservation. It won't go less than this. It cannot be 255.255.0.0 for class C network, which is ranging between 192 to 223. Can be this 24-bit, or it can be more than 24-bit, but it cannot be less. So we saw a default subnet mask. We saw the meaning of subnet mask. Subnet mask simply tells how many bits in the above address is given for the network. How many bits are used for network. All right, next is the address size is okay. We'll talk now. You see, after 223, there is no address you can assign to any computer. Then what happened after 223 to 255? If you take an octet, you have 8 bit. Sorry, you got 8 bits. So using that 8 bit, we derived class C, and you saw class C is 1 to 126, class B is 128 to 191, 192 to 223. Now, what happened to the number between 224 to 255? What happened to this? Actually, this 224, first of all, let us begin from here. How you got this one? The first octet, first 2 bits are like this, third bit is like this. And then the remaining 5 bits are, okay, 5 bit. Now when all these bits are zeros, you got 192. Is that right? 128 plus 64. And when all these are ones, you got 223, meaning 255 minus 32. 255 minus the 0 is 32. Now, to derive class D, which is called multicast range, for this to derive class D, instead of 0 here, you got 1. But 0 here. And now, the minimum is 224, isn't it? 128 plus 64 plus 32. And then the maximum is 255 minus 16, 239. But this is not a valid IP address. That's why I did not touch this area. This is multicast address. You will not be assigning this address to any of the hosts. This is to identify group of hosts, not a single host, but a group of hosts. This is not an IP address. This is a multicast IP address.
So in which case you use the multicast for
Many cases, in a conference room, let's say there are 10 people sitting in a conference room, and there are mics, there are mics in front of them. Assume that those mics are controlled by software. Now, this story may be valid or invalid, but I'm just trying to explain you how the multicast is used, in what scenario we can use it. I don't know about the mic that the people use in conference hall, but you see, when we have online conference, this is how it will work. What I'm saying is what going to happen. But I just want you to imagine, like, everyone have got their mic maybe in front of them, a laptop with a mic and all are sitting in the same room. Only then you will understand easily. Group. Now, I press the mic on button and I speak. When I speak, everyone can hear my voice. Likewise, when my neighbor press the button and speak, I also can hear. Earlier when I speak, the entire group was hearing. But in my office, there are many conference rooms. They don't hear my voice, but only those who are within this room hear my voice. They're also connected to the network, but they don't hear my voice. Only those who are inside this room can hear my voice. Likewise, when my neighbor press the press button, talk button, and when he talks, I and my friends can hear, but not someone in the other conference room can hear, though we're all in same office, same network. So multicast address is to talk to a group. See, when I press the button and talk, it identifies the group to whom it needs to be delivered, the voice needs to be delivered. It delivers the voice only to those people who are inside that conference room. So here the conference room is what the multicast addresses. The conference room, why the word I am using conference room, just to show you a group of people sitting in a room. Likewise, when I say multicast address, group of device that is identified with a common address. See, every device will have an IP address of their own, unique IP address. On top of that, you have another identity. But this identity is not for you alone, it is for group in which you are included. For example, there may be a child in a class called Jenika, Janvika, Sanvika, Alvika. Lot of Vikas today. Now, though they got their own names, but still they are called as UKG B section. That's the multicast address. UKG B section. When we say UKG B section, it includes Janvika, Jenika, Sanvika, Alkas. So they got two names now in school. If someone calls Jenika, a girl from UKGC, B is going to come. And when you call UKGB, then also the same girl comes out from the classroom, but along with many, because you called UKGB. So, hope you understand. Multicast. Multicast addresses helps to identify group. Now, we got this range, 224 to 239. Is a multicast range. After 239, so far no one has decided it is still under experiment, class E. After 239, it is still under development, experiment. It is not decided, not defined how to use to. So you will not find any address starting from 242 to 255. It's not so far. It is still told us under the research and development. Okay, that's it. Now, as we all know, the IP address is 32-bit size. 32-bit binary. (32-bit binary number. IP address is 32-bit only. 32-bit. So with this 32-bit, maybe you will get like 5 million IP address. Happy. No. On those days, they were happy. thinking that wow, we are going to have 5 million IP addresses. Actually, 5 million is not much. And maybe South India will get IP address, rest all of the world will be without IP address. They will not be able to communicate with that 5 million. Very small number, 5 million.
Yes.
So, identifying a device uniquely with an IP address is not possible because mm, only only 5 million. How can you identify every device on earth with this address? But anyhow, in order to manage, we have a solution called NATing, network address translation. Actually, I should not get into this topic too early for you, but because you have gone through self learning of this area, I'm just touching this area now. This 32-bit is not sufficient for the entire world. So we have a private and public scheme of address.
Range. Mm-hmm.
So
Then,
private addresses are not routable in the internet.
internet.
Yeah, so we got only the public range of address in the public domain for routing.
Yes.
So if a company have got 10,001 address, there may be another company who is also having 10,001 address. And this company has got like 2,000 employees, all have got 10 IP address. This company may also have 2,000 employees, all having starting with 10 address, 10,001, 10,002, 10,003. Like, then if this alpha wants to talk to beta, how they are going to communicate? Actually, they will be connecting to a public network called internet.
ISP.
Yes, service provider, internet service provider, ISP. And then ISP will give a public IP address, a unique IP address, let's say 1.0.0.1, 1.0.0.2. 1.0.0.2. So here we see these 2000 devices are going to be represented to the public network with this IP address 1001.
Mm-hmm.
Likewise, these 2000 are going to be shown to the world as 1002, which we called as natting. Instead of showing the original IP address, they show the IP address on the WAN side of the router. This is wide area network side. This is LAN side, isn't it? Am I right?
Yes.
Yeah.
That's the last. Okay.
Mm.
If nothing can be done with the help of router, or we need the firewall for this.
Mm. That can be done on a router.
Okay.
There's no
Is that
necessary.
feasible, or like adding more, utilizing
Mm.
more
No,
CPUs?
those stories and all people will tell all those stories for, for the beginners because beginners will listen to anything that we say. Okay, but that is not real story.
Okay.
You can put netting on any device uh, because if you say we're giving more pressure, it's not a human brain. Human brain, whatever God created, that is the limit. You cannot keep growing beyond. But the machines are not like that. Okay, fine. If it is more pressure, change the processor, more speed processor, put more RAM. More ASIC
In
chip.
real time, they do
Yeah.
not count.
Yes. 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 Just for this reason, I cannot buy one firewall.
Mhm.
The purpose of NATing is different. The purpose of firewall is different. Firewall's job is to protect. This is hide and seek game. NATing is not a protection, but people will claim that it's a security feature. How they say no? They will say, we are not revealing our original identity. We are just we are going to show our 1.0.0.2. No one will know my original identity. Mm. That's why I said hide and seek game. Because you are hiding, you are not safe. Don't think, I am hiding, so I'm safe. No. Even when you are exposed, when someone cannot attack you, then that is real security. Hiding behind one stone and saying, I'm safe, I'm safe. This is funny. Natting is like hiding behind a stone and saying, I'm safe. So, natting is not a security feature.
Okay.
Natting is supposed to be done on a router.
Mhm.
Firewall's job, firewall will do. This is routing job. Private addresses cannot be routed in public. For the routing to happen, I do this translation of address so that I'll get I'll get a new identity which is routable in the public. That is natting.
Mhm.
So we make a non-routable packet to be a routable packet by changing the source IP address before sending the traffic out to the public. That is what natting is. Okay, now coming back to the story. We got private address and public address for this purpose. And now the public addresses I do not want to write. If I write private, all the rest are public. In private, 10.0.0.0 to 10.255 255 is private. Likewise, 172 dot, listen here, 172 dot not 0 or 1 I'm putting 16, which means 172.5 is public.
Oh,
172.15 is also public. 172.16 only private starts. Uh, 00 till 172.31. 32 means it is public. 31.255. This is what? Private. And then 192.168 dot, you need to focus in this place. You see it's 0 here. Till 192.168.255.0. So there is really 255 different private addresses in this class. See. So if you have 192.168.0, that is one private address. 192.168.1, this is another private. 2 is another private. Likewise, you can have up to 250. Likewise, here 16, 17, 18, 19, up to 31 private. So apart from these range of address, rest all are public.
okay.
Now we are going to another part, which is subnetting. Why do we need subnetting? Why do we need subnetting? Subnetting is to break down a network into small networks. Why? Because I got small network. I want to have small networks in my organization. Why? Because I got many departments. I do not want all the departments in same network. At the same time, I do not want to give different network. Like, I do not want one department in 10 network, another department in 172.16 network, another network in 192.168. I do not want this. I want my entire company's network to begin with, let's say, 10. Only 10. All the departments' network should begin with 10. At the same time, I want different network. How it is possible? I want only the 10 network to be used in my office. But I want multiple 10 networks. எப்படி இது சாத்தியம்? How is this possible? One network, how can I have many networks? That is what we call it as subnetting. So your company norms will say, thou shall not use any other network other than 10. That's the policy. So we have to now do something so that you can have multiple networks out of this 10 so that I can give each network to each department. So if anyone wants to go from department A to department B, it is possible only with the help of a router, otherwise not possible. If they are not connected to a router, they will not be able to communicate, even though this IP address of this computer is 10.0.0.1. This IP address of the computer is 10.50.1.1. This IP address is 10.97.1.1. Even though they all begin with 10, they are not of same subnet. The mask is 255.255.00, 255.255.00, 255.255.00. Now, you see two octets are masked, which means this is 10.97 network, this is 10.50 network, this is 10.0 network. Are they same? No.
No.
How do I know? Mask says they are not same. This is 10.0 network, this is 10.50 network, 10.90. Because they belong to different network. They will not communicate with a switch. Having a switch here is of no use. Even if they are in same VLAN, it is of no use. They will not communicate because the layer 3 is not same. When you put all of them in same VLAN, layer 2 is same, but layer 3 is not same. Both needs to be same for communication. So that is what you need actually. The company wants each department to have their own network. They don't want to be in same network because it's not same department. Because they're not in same department, they should have different network. That's the requirement. To meet this requirement, to provide this, to make the company feel secure, we need to provide different networks so that you can have an ACL or something to provide security to between these departments. Because they are in different network, in order to communicate between department B and A, they will definitely go to the router. B needs to go to the router and router will route it to A. Likewise, A will go to the router and router will route it to B. Without the help of router, they cannot communicate. So when they go to router, I'll have access control list there to decide who can talk to whom. You see, it's a security.
Mm-hmm.
Subnetting helps to have,
That's the access list.
yeah, the control, access control list. Okay, so now subnetting, why subnetting? Answer is we are not having one big department in an organization. We got multiple small departments which needs to be managed separately. For that, I need separate network for each department. We call that separate network a subnet. Fine. Now, how subnetting? I already gave you a clue how subnetting. The default mask is actually 255.0.0.0. By increasing the mask, meaning what is the other meaning of this? By increasing the number of bits for network, we can have new networks out of the old one. We can have new networks out of the old one. You see, you are not going to change this number 10 anytime. It is always the same. Because the first octet is masked, you cannot change this first octet. Only thing you can do is you can add additional bits to the network in order to make new networks. Right? 10 network is like pachai. In that pachai, light pachai, dark pachai, milky pachai. So you can keep adding little white color to the green paint, and you can say light green, and then you don't mix any white in it. Then dark green. Then you mix a little bit less white and call milky green. You can keep making likewise. Like you added white paint to the green paint, you need additional paint. Likewise, you need additional bits for network. Yeah. So in short, subnetting is having new networks by adding extra bits for networking to the existing reserved bits. This is my own definition. Now, let us try to understand again more in depth why we need subnetting. Already we saw one reason different departments need to be managed, controlled differently. So we need subnetting. Secondly, we need subnetting because if all the departments are in one network, then there will be only one broadcast address. If all departments are in one network, if all the departments are in one network, then there will be only one broadcast address. So what's the other side of it? When we have multiple departments with multiple networks, each department will have their own broadcast address. What's the advantage? If you want to send a layer 3 broadcast, you have a dedicated broadcast address for each department. For example, in the previous diagram here, the broadcast address of this one is 10 dot. Because it is masked, I cannot change this second octet 0, and 255.255. This is the broadcast address of Department A. Department B is 10.50 dot, because it is masked. Second octet should be 50. 255.255. And this one is 10.97.255.255. This is the broadcast of Department C.
The last address.
Yeah. So the departments have got their own network as well as their own broadcast address. Any traffic that is sent to this address will impact only these department people. Others will not. That is good. We don't necessarily disturb the other members of the department, other department.
Also, geographically, we can group them.
Yeah, that is true. Right now, we are going to do an example. Let us say I have like 7 department. Next is we are going to have an example. This is an organization with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7. So how many departments we got? 7 departments. 1, 2, 7 departments. I really don't like this. Yeah. So we got 7 departments. And the company norm says you should use only 172.16 private. You cannot use even 172.17. Not allowed. Only 172.16. That's the company's rule. Anywhere, whether it is in London, a new government is going to be formed, whether it is in Afghanistan or Australia or Canada, wherever, the address of the company, they all same company everywhere in London and Afghanistan and Canada, in South Africa. They have same company, but in different geographical region, as you said. You want to see only 172.16. when you move around your company to do supervision, you're a supervisor, you go to the different countries and different companies and check the network. So you go for an inspection and you want to see only 172.16 everywhere. Maybe for Australia you want to have 172.16, some number here different from Africa. So
Okay.
whether it is same geographical or different geographical, what we are going to do is same. Um, Now we got 7 departments. You can say 7 departments or 7 regions of the earth. It doesn't matter.
Mm-hmm.
Now, how do I get 7 different departments out of this one network? The default mask is 255.255.0.0. This is the default mask. Now I need to break down this into 7. How? You cannot disturb the first 2 octet because they are masked. You got a privilege of doing anything with these because here it is 0. Because here it is 0 in the subnet mask, which means you got full rights to do some changes to these 8 plus 8 bits, 16 bit.
Mm-hmm.
You have rights. Fine. So because we are dealing with network, you cannot change from this end. You should change it from this end. See, network is from always from left to right. If you see class A, this is the network.
Yes.
Class B is not coming here like 15 or something. No, it is going from 172 to 16. It is here. So network always grows from left to right bit. Host will grow from right to left bit. Host. Now we are dealing with subnetting. It is network. We are dealing with network. If you are dealing with network, you should go from. You should take bits only from the left hand side, available bits, not the right hand side. But when you are dealing with host, you need to take it from the right hand side. So we are going to take some bits from this octet and mask it to be a network bit. That is what people used to say. We're going to borrow, borrow, borrow. Come on, till the death they want to borrow. I don't understand. It's educational loan borrowing, car loan borrowing, house loan borrowing. Borrowing when you are going to live your own life. You still want to be a slave till you die. Borrowing even in subnetting. I don't understand this life. So I'm not going to use the word borrowing because I don't like borrowing. And what I'm saying here is we are going to give. Giving is more good than taking. We are going to give for network. And we are going to reserve that. That is what masking. We are going to reserve those given bits only for network and we will not use it for host, which we use it as a solution to have multiple networks. See, if we want to have that light pachai, dark pachai, and ordinary pachai, for that I need some ink, white ink. I need some bits. That's what I'm going to do now. Right now, how many bits I should take from the host? I already told you we need to take from the left hand side, but how many bits I should take is what we need to derive. For that, there is no big difficult formula, very simple formula. Because it is binary, you put 2 to the power 2. 2, why 2? Because it's binary. 2 to the power of n. N is the number of bits that you want to give. N is the number of bit that you want to give minus 2. This will give you number of subnets. But later they said no, it is not 2, it is going to be 1. That will give you a number of subnets. I'll come to this old formula later. Let me use the latest one. Later I'll tell you what was the problem with this old one. Not now. I don't want to waste much time, so we'll keep it for later. Now currently, this is what we do. 2 to the power of n minus 1 will give you the number of bits, will give you the number of subnets. Okay, now 172.16 and this 8-bit and then the last octet. So we said that we are going to give from these bits. We are going to lend some bits. We are going to take some bits and make it as a network bit, and it should start from left, not from the right. To decide how many we are going to give, we have this formula. So let's put this 1 bit. I want to give only 1 bit. 2 to the power of 1 minus 1. Nothing. I'll get only 1, but what is that 1? No subnet. It's the same one. I already have one network. 2 to the power of 1 minus 1. I'll get only 1. I already have one network. Actually, I want 7 networks. Fine. Then let's put 2 bits. 2 to the power of 2 minus 1. Again, I get only 3, which is not sufficient. Okay, then let's put 3. As I said, n is the number of bits that we want to give. So 3. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 3 times 2 is 8. Minus 1 is 7. Wonderful. We got 7 departments. So you're going to get 7 subnets if you are giving 3 bits. Okay. Now we have understood how many bits we need to give, but giving this, how it solves the problem. Let's see. That 3-bit I'm writing here for your understanding. I'm writing here the 3-bit. You see that dot, 3 dots? Okay. Now these 3 bits can be 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1. These are the different possibilities when you toss 3 coins together. You might have learned in college days, discrete mathematics. Now, probabilities. So 1, 2, 3, 4, 5, 6, 7, 8. 8 different possibilities, 8 different probabilities you get when you have 3 bits. Now, you know why this minus 1 in the formula? Because we are not supposed to use all ones. Why? I'll tell you later. So now how many subnets you have? 7 subnets you got when you put minus 1. See, this is for the first subnet. 172.16.0.0. What is the new mask? 255. 255 is old mask. In the third octet, see how you got this 255? Because you got all the 8 bits for network. So in the second octet also all the 8 bit for network. But in the third octet, how many bits you gave for network? Not all 8 bit, only 3 bit. So when you add this 3 bit, you will get 224. So this is the new subnet mask. New subnet mask. If you don't put this one, then it is no point of subnetting. Now, this is the first department's network. Second department, this one, you see, 0, 0, 1. 0, 0, 1. What is the value in this place? 32, isn't it?
Yes.
So 172.16.32.0, 255.255.224.0. Same subnet mask for all. Okay, next.
Yes.
For the third department, can you tell me this one? We are going to put this one here. 10010.
172.16.64.
Exactly. 64.0. 255.255.224.0. Likewise, if you okay, let me quickly do it. 172.16.96.0. How 96? Because 64 plus 32. You agree?
32.
And then 172.16.128.0, 172.16.160.0. Yeah, this one, 160.
Yes.
And then 172.16.192.0, this one. And this one you should not use. 172.16.224.0. Why? Because it's already in the mask. You have given those bits for networking. You cannot use it.
Okay.
You cannot have a host having 172.16.224.1. Not possible. Because the 224 and all given for network. Now, that's why the -1. Now I want to cover this one. Why earlier they were having -2? Earlier they were not even considering this one. Earlier they were not using this subnet.
Okay.
So later they realized, we are wasting. And so they changed the formula to -1 and they started using the zeroth subnet. Earlier they were not using zeroth subnet. So earlier they were saying all 0 and all 1s we don't take. When I started my CCNA in 2003, this is how it was. All 0, all 1 we won't use. And later days, the forum realized that we are wasting. See, in this in the zeroth subnet, if you see, you will get the first IP 172.16.0.1, correct?
Yes.
The first
And
IP.
250.
No, 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 no. And then the broadcast will be, because there is no space, I'm writing here 172.16. The next network is 32. Okay. So here it will be ending with 31.254 because 255 is a broadcast.
55 the broadcast.
You see, initially they didn't realize that we are wasting these range of address from 0 to 31. From 0 to 35, in 0 you have 255 network. Again in 1 you will have 255 network. In 2 you will have 250 up to 31.254. These many thousands of IP address were wasted initially. You understood?
Yes.
So the formula is no more -2, it is -1 because we now start using the zeroth subnet. We are simply not using this one because these bits are already used. All ones we don't use it. Are you fine with what we have covered so far?
Yeah, I'm good.
All right.